I'm analyzing how scikit-learn's LarsCV, least angle regression with cross-validation, stores its mean squared error, MSE, information in the MSE_path_backquote attribute. I'm focusing on understanding the structure and meaning of this data. It's all about understanding how LarsCV uses cross-validation to find the best model. LarsCV is a machine learning algorithm. It's a type of linear regression that adds variables to a model one by one, based on how well they predict the target variable. The Lars stands for least angle regression, and the CV stands for cross-validation, meaning it uses multiple subsets of data to make sure the model generalizes well. I'll be looking at how it helps choose the right number of features. In the context of LarsCV, cross-validation means I'm splitting the data into multiple sets, folds. I train the model on some folds and test it on others. This helps to estimate how well the model will perform on unseen data. It reduces the risk of overfitting, meaning the model won't work too well only on the data I used to train it. For each fold in cross-validation and each model I build, I calculate the mean squared error, MSE. The MSE measures the average squared difference between the model's predictions and the actual values. Lower MSE means a better fitting model. I'm basically averaging the errors to get a measure of how far off the predictions are from reality. The MSE_path_backquote attribute in LarsCV stores all the MSE values calculated in step 10. It's not just one number, but a collection of numbers organized to show how the MSE changes as more features are added to the model. I can use this information to figure out the best model to use. It's the path to the best model. This statement is correct. I think of MSE_path_backquote as a table. Each row of this table represents a different data fold from cross-validation. Each column represents the MSE for a model with a different number of features. I'm looking at the error across different sets of data and different model sizes. It's a very detailed table. This is wrong. While MSE_path_backquote helps me find the optimal number of features, by showing me which model has the lowest MSE, it doesn't directly give me that number. LarsCV stores the optimal number of features separately. It's like a treasure map. MSE_path_backquote shows me where the treasure is, but I still need to dig it up. This is also correct. The Lars algorithm uses a parameter called lambda for regularization, controlling the complexity of the model. Each column in MSE_path_backquote corresponds to a different lambda value, showing how the MSE changes as lambda changes. It's like tuning a knob. I can see how the result changes as I adjust it. This is incorrect. MSE_path_backquote is a 2D array, a table, not a 1D array, a list. It contains MSS for all models and all folds, not just the best one. I need to keep in mind the difference between a list and a table. LarsCV, which stands for least angle regression with cross-validation, uses MSE_path to store its results. I'll explain it simply. Imagine you're baking cookies, trying different amounts of sugar. MSE_path keeps track of how good each batch tastes, measured by mean squared error. Think of it like a spreadsheet. Each row shows how well the model predicted values using one of your cross-validation folds. Each column shows how well a model did with a different number of variables, features. This helps us find the best combination. Remember cross-validation? We split the data into multiple parts, train on some, test on others, and repeat. Each row in MSE_path represents one of those test parts. I show the results of that test in the form of the mean squared error. Okay, so each column represents the outcome when I use different numbers of features in my model. The number of features corresponds to the value of lambda. Lambda is a regularization parameter, controlling how much I avoid overfitting my model. A different lambda value gives a different amount of features, and therefore a different mean squared error. Each column shows the mean squared error for a particular lambda value. Lambda is a crucial parameter in Lars, least angle regression. It controls the complexity of the model. A large lambda value leads to simpler models with fewer features, while a small lambda value leads to more complex models with many features. This is to avoid overfitting and improve generalization performance on unseen data. The mean squared error is a measure of how well the model fits the data. Smaller values indicate a better fit. MSEPATH contains all MSEs, one for each possible lambda used in the LarsCV process. This is wrong because MSEPATH is not just about the best model. It stores the MSE for all models I tried, during cross-validation. It's a 2D array, not a 1D array. This refers to a specific attribute, MSEPATH, within the scikit-learn's LarsCV, least angle regression with cross-validation, model. I'll explain what it means and how you interpret it. It's a key part of understanding how LarsCV selects the best model. Imagine a spreadsheet. Each row represents one of the separate tests LarsCV runs as part of cross-validation. Each column shows the mean squared error, MSE, a measure of how well the model predicts, for a different number of input variables, features, used in that test. Lower MSE is better. The least angle regression, LARS, algorithm uses a parameter called lambda. Think of lambda as a dial that controls how much the algorithm simplifies the model to avoid overfitting. Each column in MSEPATH shows the MSE for a different setting of this lambda dial, showing how MSE changes with the model complexity. Nope. While MSEPATH helps LarsCV find the best number of features, it doesn't state it explicitly. The best number is determined separately by looking at the lowest MSE value and is stored elsewhere in the model's results. Incorrect again. MSEPATH isn't a 1D array, it's actually a 2D array. And it doesn't only show the MSE of the best model, it shows the MSE for every model considered across all the cross-validation folds. I'm talking about the MSE_path_path_ attribute from the scikit-learn's LarsCV function. It's a key piece of information that helps us understand how well the model performed during the cross-validation process. LarsCV stands for least angle regression with cross-validation. It's a type of linear regression. It cleverly adds one variable at a time to the model, based on how well each variable predicts the target variable. The cross-validation part means it tests the model's performance on different subsets of your data to ensure it generalizes well. Cross-validation is a super important technique in machine learning. I use it to avoid overfitting. That's when my model performs fantastically on the data I trained it on, but poorly on new, unseen data. In cross-validation, I split my data into several folds and train the model on some folds, then test it on the remaining fold. I do this repeatedly with different folds until I test it on all folds. Then I average the results to get a more robust estimate of the model's performance. This statement is correct. Imagine a table. Each row represents one of the cross-validation folds, and each column shows the mean squared error, MSE, a measure of how well the model predicts the target variable using a specific number of features, variables. Lower MSE means better performance. Absolutely right. The LarsCV algorithm uses a parameter called lambda for regularization. This helps prevent overfitting by controlling the influence of each feature. Each column in MSE_path_ corresponds to a different lambda value, and the MSE shows how the model performs with that particular regularization level. Nope. While MSE_path_ helps me find the optimal number of features, by showing which model had the lowest MSE, it doesn't directly tell me what that number is. I would need to look at another attribute to find the optimal number. Incorrect. MSE_path_ is actually a 2D array, not a 1D array. It contains the MSE values for all the models considered during cross-validation, not just the final, best, one. I see the MSE_path_ attribute as a table. Rows represent the results from each separate experiment, fold, during cross-validation. Columns show the mean squared error, MSE, which is a way to measure how well the model predicts, for different numbers of features used in the model. Each cell within the table shows the MSE for one fold and one model, i.e., a specific number of features. Think of it like a spreadsheet tracking model performance across experiments with varying complexity. These are like separate, smaller experiments using different subsets of your data, used to train and test the model separately, ensuring you get a reliable measurement that generalizes well to new, unseen data. Each column represents a model trained using a different number of input features. Remember that least angle regression, LarsCV, builds models incrementally, adding features one by one. Each column reflects a stage in this process, and each stage corresponds to a specific value of lambda, the regularization parameter controlling model complexity. Each cell contains a single number, the MSE for a particular model, number of features, calculated on one particular fold. A lower MSE means better model performance in predicting the target value. It's like a score for how good that model was on that particular test. This question challenges you to understand the structure and meaning of the MSE_path_path_ attribute. Let's break down what each part shows and how this helps you to find the best model. This refers to a specific attribute within the scikit-learn LarsCV least angle regression with cross-validation object. This attribute holds the results of its calculations and is crucial for choosing the best model. LarsCV, by the way, is a technique that combines the Lars algorithm with cross-validation to select the best number of features for a regression model. The MSE_path_ attribute in scikit-learn's LarsCV least angle regression with cross-validation holds the key to understanding how well the model performed during cross-validation for different numbers of features. I'll explain what it shows you. It's like a report card for different model versions. Let's break down what MSE_path_ means. Think of it as a record of the model's performance throughout the model building process. It shows you the mean squared error, MSE, a measure of how far off your model's predictions are from the actual values, for different numbers of features used, across different cross-validation folds. The MSE_path_ attribute is a 2D array. I picture it like a spreadsheet. Each row represents a fold in your cross-validation, meaning it shows the results of training your model on a different portion of your data. Each column represents a different model version, using a different number of features, so you can compare them easily. Each column in your MSE_path_ spreadsheet holds the mean squared errors, MSE. The MSE value represents how well the model version using a particular number of features predicted the outcome in that cross-validation fold. Lower MSE is better. It tells you how accurate that particular model was. The question focuses on understanding the meaning and structure of the MSE_path_ attribute. We are breaking down what it represents in a way that's easy to grasp. We're covering what information is contained in the rows and columns of the array. It's all about visualizing the process that LarsCV uses to determine the best number of features to include in the model. This is correct. Each column in the MSE_path_ array is linked to a specific lambda value. Lambda is a parameter that controls the amount of regularization in your Lars model. A smaller lambda value means less regularization, allowing the model to become more complex and possibly overfit. The MSE tells you whether you've found a good balance between complexity and predictive performance. The MSE_path_ is a 2D array because it shows the results across multiple cross-validation folds, rows, and for different numbers of features in the model, columns. This structure allows you to see the performance of different models for different folds and choose the best overall. Each row in the MSE_path_ array represents a single fold in the cross-validation process. Think of this as a separate training run using a different subset of your data. This gives you a better idea of the model's performance on unseen data and helps prevent overfitting. This refers to a specific attribute, MSE_path_ within the scikit-learn's LarsCV least angle regression with cross-validation model. I'll explain what this attribute represents. It's a key piece of information that helps us understand how well the model performs during its training process. This question asks you to identify which statements are correct regarding the MSE_path_ attribute in the LarsCV model. We need to analyze what this attribute holds and which descriptions are factually accurate. This statement is true. The MSE underscore path underscore attribute indeed stores the mean squared error, MSE, for each lambda value considered during the least angle regression path. Remember, each lambda value represents a different level of regularization, a way to prevent overfitting, and affects the number of features included in the model. This is also true. The MSE underscore path underscore is a 2D, two-dimensional, array, meaning it's like a grid. Each row represents a single fold from the cross-validation process. Each column reflects the MSE for a different number of features, equivalently, different lambda values, in the model. So you have a nice summary of MSEs, covering different regularization strengths and evaluation folds. This statement is false. The MSE underscore path underscore helps determine the optimal number of features. However, it doesn't directly give you that number. The optimal number is determined separately by finding the minimum MSE value. This statement is false. The MSE underscore path underscore does not represent only the best model's MSE. It actually represents the MSEs across all folds for all models considered, varying in the number of features. It is not a 1D array, but a 2D array.